Thank you very much for the introduction. Let's see. I propose we're facing some serious issues in the 21st century. And no, I don't mean the election results from last night. But do you know how much water you're wasting, and I'm using the term wasting in a loosely form, when you shave your legs while you're showering? Would it surprise you if I tell you it's about 8 gallons? And these 8 gallons could provide fresh drinking water for a child in Africa for about 2 days. The energy that we're using to heat up those 6 gallons could provide electricity for a child in Africa for about 5 days, roughly. So I'm here to talk about issues related to energy, water, and waste, right? Creating a sustainable environment. There are other issues. We heard about sustainable food supply, right? But let's focus on those first. To live in the future, I propose that we need to generate our energy on site. So we can put solar panels on the roof. We can put a wind generator on the roof, depending where you live. We can use geothermal heat to provide maybe heating and cooling of your home. And you can even use solar energy to create hot water for your home. To live in the future, I propose that we need to collect all of our water. So we use that on site. We have appropriate collection mechanisms. We have appropriate sanitation mechanisms. And we can use and store it. In the future, or to live in the future, I propose that we recycle everything that we manufacture, meaning the company that manufactures has to take all products back. We're using maybe composting toilets. We're using anything that's related to food waste locally for composting. So those are some nice ideas. I think you would agree with me. So the question is, by when is this happening? And would it surprise you if I tell you that the future is today? Meet the Renew House. The Renew House stands for Retrofitted Net Zero Energy, Water and Waste Home. It's a home that was built in 1928, and it's located just a little bit east of the McDonald's at the intersection of Stadium and Northwestern here on campus, or close to campus. It's owned by the Purdue Research Foundation, and we have leased it. We are currently in our 4th year with another 4 years to come. The floor plan says it has about 2,800 feet on the basement floor, 1st floor, and 3 bedrooms on the 2nd floor. We renovated this, as I mentioned, by using only local resources, and we have real occupancy. What I mean by that is 3 of my graduate students are using this as a playground. Right? They're living there in the 3 bedrooms upstairs, and they're using the basement as a fully functional laboratory. And we are fully instrumented with a monitoring system. I will talk a little bit more about that in a little bit. Here are some photos from the inside. You will see we have a beautifully renovated inside kitchen. Open labs, kind of open space environment. We have an open living room, and we even have something that the industry called a bio-wall. That means we're not using chemical filtration systems to renew the air inside the house. We have the air going through the bio-wall, taking out VOCs and using as a filter, and then is conditioned, either heated in the winter or cooled in the summer, and then return to the space. So it provides what we call a very comfortable and a very personal living environment. Here's a photo of the building or the house when we renovated it on the outside. We took all the paneling off and then we sprayed it with a very new spray foam with a very high insulation value. That are those R values that are listed there. We also sprayed out the attic. We replaced all windows with triple pane windows as well as the doors with high insulation doors. Everything is very leak tight to make it very high efficient to reduce our heating loads in the winter and our cooling loads in the summer. After we did this, of course, we put the paneling back on. So we want to be net zero energy, right? So how do we how do you get to net zero energy? You need to produce energy, right? We're doing this with solar panels on the roof, but as you easily know, sun is not shining all day, right? So you need storage. We are lucky we can use the grid as a storage. So during the day we have overproduction, which we're feeding into the grid, and then at nighttime we're taking that electricity back off the grid for the needs inside the home. Duke Energy was nice enough. They gave us a great rate. We can sell them the electricity exactly at the rate that we're buying it back. So that's cost neutral for us. But we not only have the solar panels, the photovoltaic panels, we also have integrated warm water. So these panels are a brand new design. It has a PV and then a thermal components on the backside, where in the summertime we can heat up water almost to shower temperature. Not necessarily in the winter, but we can still produce warm water when the sun is shining in the winter. That water goes into these 3 storage tanks that you see on the bottom left, and has a dual function. As I mentioned, we can use it for warm or hot water in the home, but we can also reverse the flow, and in the winter time when it's snowing, we can heat up our panels and melt the snow off, so we have electricity production in any kind of weather. We have a ground source heat pump. That means we have 3 boreholes that are about 280 feet deep vertically, and in the winter we can pick up heat from there that is boosted with the heat pump to provide the comfortable living environment. In the summer we are taking the heat from the house and putting it back into the ground. We also try to be net zero water. We put a metal roof on the house and we're collecting all water that goes into the downspouts and into large 2 storage tanks that are put into the ground that you see on the photo. From those storage tanks, the water goes into the house through an extensive filtration system to prepare rainwater to drinking water quality. That water is used in all faucets as well as in the shower heads, and from there it goes actually back into the basement into a secondary preparation system. It's at this point called gray water. We're preparing the gray water one more time, not to drinking water quality, but to a quality that allows us to use it in the toilets, and then after that it's actually discharged to the canalization of the city. Finally, I would like to mention we are fully instrumented, right? So we can measure temperatures and the humidity and airflow throughout the entire house. We can measure the electricity that we use at every outlet of every appliance in the house. We can use the water use at every faucet, at every shower head, at every toilet of the house. I started out by asking this woman if she knows how many gallons of water she uses, right? So let me go back. This is our shower study, right? I can tell you exactly how much you use for the pre-wash, for face washing. I can tell you if you should use shampoo and conditioner 2 in 1, because it takes less water than shampoo and conditioner separately, right? I hope I showed you a little bit of the glimpse of what we're doing with the Renew house, and I hope that you can see that you can live already a very sustainable today. Thank you very much.